Okay, so another interesting tidbit about polynomials is what we used to call x-intercepts. We're going to give them a new name. As a matter of fact, I think our calculator already calls them zeros. I think if you guys recall finding some x-intercepts with our calculator, the button we pressed was a 0, and that you're going to figure out why in a moment. So let's do some theory, and then I'll slowly put that theory into action. We'll use some technology to help us with some more understanding, and we'll start learning about behavior of polynomials at their x-intercepts, or what we now are going to be calling their zeros. So here's the theory. We're going to begin by letting p of x be any polynomial. So think of any polynomial of any degree, first degree, second, third, fourth, seventh, eighth, whatever the case might be. If the number c is a zero of the polynomial, then the following statements, a, b, and c, are all equivalent, and that's pretty powerful in math, because that means if I have one, I have the other two. Alright, so if we observe one aspect, we can automatically assume the other two. So first of all, to be a zero, that means that it's an input value that if I put it into the function, its output is 0. And that leads to the next conclusion, because if our input is c, that's x, and our output is 0, that's y, that means the point c0 is actually an x-intercept on the graph of p of x. Okay, so hopefully these two kind of go hand in hand. And then something that's really kind of new to us, but it's not, is that x minus c is actually a linear factor of the polynomial p of x. So what am I talking about here? Well, c is the 0, so if I subtract it from x, right, I have a factor or a piece of something that is involved in the product of the polynomial. And the reason I'm calling it linear, because if we looked at this alone, this is a degree 1 polynomial. So we have a linear factor of the polynomial. So rather than trying to explain that in words, let's just go look something from the past, right? So from the past, we solved things like x squared minus 8x plus 12. You're actually going to see all of this in action by just reviewing what we did in the past. Classic way to solve this is to factor. Right, and when we think about factoring this, x times x is going to give us the x squared, and then we need to multiply up to 12 but add up to negative 8. And I believe negative 6 and minus 2 are going to do the trick for us. So you'll notice at this time by factoring, hopefully you see that I have two linear factors, right? And our c value is really, really close behind. We learned that at the zero factor property, I would set these both equal to 0. Do an addition, we get x equals to 6, and we get x equals to 2. So this particular function had two c values, right? We know that p of 6 is going to be a 0, so I'm trying to demonstrate this part. So if we squared the 6, and 8 times 6 plus 12, well, 6 squared is 36. 8 times 6 is 48, and then plus 12. 36 plus 12 is 48. Minus 48, what we get is 0. So 6 is a 0 because it's in a value that when I plug it into the function, gives me an output of 0, and x minus 6 happens to be a factor of the polynomial. Same thing with the 2. If we looked at p of 2, plugging that into the function, we get 4 minus 16 plus 12. 4 and 12 is 16, and we get 0. So 2, right, is a value that when I plug it into the function, gives me an output of 0. And of course, what this also means in terms of a graph is that the point 6, 0 and the point 2, 0 are actually going to be x-intercepts for this graph. So there's something we did in the past, and we were doing this all along. We're just now technically calling it something. We're calling 6 and 2, we're calling them zeros. And what again that means is the function value at 6 and 2 is 0. Visually we have an x-intercept at 6, 0 and 2, 0. And algebraically, x minus 6 and x minus 2 are graphs, or excuse me, are linear factors. And let me just go ahead and go to my graphing calculator, and let's kind of just see that in action. So let me go to y equals, oops, got some stuff here, let me clear that out. And we're going to be graphing x squared minus 8x and then plus 12. And so when I go graph that, where you do get a parabola, and notice that it is in fact intersecting, right, our graph at 2, 0 and intersecting our graph at 6, 0. So that is a really cool aspect about this material. So if we on a graph observe my x-intercepts at some locations, I can automatically assume that I have a 0 of my function and that I have a linear factor of that function. So there's some theory for you. Now what we're going to do is kind of put that into work and do some things with that theory. Alright? And so let me go ahead and start that in a new video and start kind of fresh. See you guys in a moment.